everyone. Welcome to Manufacturing Hub. Very excited to continue our robotics theme today. If you guys are wondering why we are going live with Courtney on a Tuesday as opposed to a Wednesday, we've actually got a special 2 Manufacturing Hubs this week. We tried desperately to get Courtney on last week, and then if anyone was traveling for any of the 12 conferences that I feel like everyone wanted to go to last week, between the Tulip Event Operations Calling, which is where I was, and Pack Expo and FabTech and all of those, it was one of those. There was no chance that we could possibly have this conversation live with Courtney, and we absolutely wanted to have this conversation live with Courtney. So we've got a special episode 1 today, and then we'll have an episode again tomorrow, normal time, normal place, Wednesday at 4 o'clock. And then I will say, Courtney and I both are all the way up here. So if podcast listeners were almost all the way to the top floor, and Vlad has drank 2 cups of coffee already today. So I am both excited and mildly terrified as to where we are going to go with this. Before we go ahead and officially jump in, I will say if you guys are new here, welcome. If you've been here before, welcome back. Very excited to go have Courtney on as part of our continuing robotics theme. We want to thank our sponsors over at Solus PLC and the Solus PLC robotics courses that have been put together. Vlad is already embarrassed, which is a good way to start the show, for sponsoring this theme. But without further ado, everyone welcome to Manufacturing Hub. I am Dave. This guy down here is Vlad. Today we've got a very special guest continuing our robotics theme, Courtney Fernandez. Courtney, welcome to the show. Thank you for being here.
Hey, thanks for having me. I'm excited to talk to you guys. I love the show.
Awesome. Thank you so much for taking the time to speak with us today, Courtney. Before we dive into the robotics, the technical conversations, could you give us a little bit more of a background of yourself? How did you get into industrial automation? What was your career, I want to say, trajectory like? And ultimately, where are you today?
Yeah, that's a great question to open a podcast with, and I feel that a lot of people kind of have similar answers to mine in the accidental stumbling into automation. My early career was actually in embedded systems design, and I graduated from UC Santa Cruz, so I was right in the Silicon Valley, and just not quite smart enough to be a Facebook or an Apple or a Google type employee. So I kind of fumbled around for a little while trying to figure out what I wanted to do. So I was good at, when I say good, mediocre really, at PCB design and really basic circuits. And I was fortunate enough to work for an electric vehicle company where I got to be fascinated by motors and bigger things than I really played with, because I was always focused on small electronics and stuff. So motors were big and sexy to me, and higher power stuff and bigger, thicker cables was just exciting. And I got to do that for a little while, and accidentally very much ended up in Southern California and worked for a company that does refinery inspections. And they created a little robo crawler that was powered by water. And the idea behind it was actually cool, because the water that was driving it up the pipe was also used to lubricate it, so to speak, because it was ultrasonic sensors. They were using ultrasound to check the integrity of the pipes. And really the robot itself was the cool thing to me. They broke it every manner of way you could imagine breaking a robot, including dropping it from multiple stories in the air and saving the robot, but dropping the huge circular connector that was a $75 mil-spec connector that was this big. And when they drop it from 7 stories up, all of a sudden the circle is now an oval and no longer connects to the mating half. And I just kind of started learning, to work with things that were bigger and tougher, than a circuit board or, a small piece of consumer electronic thing. So really just the idea of things that change and move and behave differently when you program them differently is far more exciting for me than circuit boards. If I do something wrong, or I've made a mistake in my design, or I change my design, the feedback is not as immediate. I got to install it in a system and just watch it do nothing to realize that I've made a mistake. Where, I make a change in industrial automation and now this thing sings at a different frequency or that thing goes faster. I can really see what I'm doing and the changes that I'm affecting in it. So really every job since the refinery job has been, I want to see something move. I want to make a change and see the change and feel the change. And, manufacturing jobs have been like that. If I get to automate a task, I really get to see how the entire process has to adapt to that change. So I'm just, when it comes to engineering, I'm kind of a systems person. I like seeing the big picture and how it changes.
Did you decide to specialize in robotics based on that like robot refinery experience, or are you pretty much kind of like all over the place with, vision systems, traditional controls? Like what exactly did you get your hands on after that job?
The answer to that question is just yes. I made a
Okay.
huge mess of everything. So I touched everything I could after that and woke up one morning and decided that I needed more debt. And so I went back to school again and got a degree that was focused on controls and robotics. And I will say in front of everybody that was a massive expense that I really didn't need to undertake to further my career, because I think I could have achieved what I achieved without spending a bunch of money on a master's degree. But I didn't have a lot of people around me that had already done the whole like, hey, I got a master's degree and I really didn't need it. So I don't regret getting the master's degree. I learned relevant things and it became a really good negotiating tool for me later on in life. But, I'm a big proponent actually of telling kids don't even, spend money on a bachelor's degree, really, if you don't need it. Be very clear on what the degree is actually going to do for you if you get it. Because if you can get your foot in the door and get the job without the bachelor's degree, or with a trade degree instead, you'll be dollars ahead in the end. But yeah, I did focus on a master's degree that was a little bit too specific.
I would definitely agree, right? Like, I think that a lot of times it stems out of not knowing what the paths or the options are. So I also did not know anything about manufacturing before completing my degree, right? And purely on showing that degree, I was able to get in. But ultimately, there's different paths to getting there. So I think that we don't do a really good job at maybe even showcasing people before they choose the degree path what's available, if that makes sense.
Yeah. I mean, it always comes back to, for me, the value versus the cost, like most things. But I was not as clear on that as I think I could have been. And I hope, to mentor other youngins who have not spent all their money on education yet to spend it wisely, or learn from those of us who maybe invested money in the wrong direction. It's just all part of a learning experience.
Absolutely, absolutely. And I guess I know the last kind of like two companies that you've been at and ultimately are at. Could you give us a bit more details what you're working on? Obviously not revealing any company secrets, but ultimately what kind of hardware, maybe software are you involved with?
Right. So a lot of people who interacted with me in the last couple of years interacted with me at Universal Robots. They make a cobot arm. And when we say cobot, it's short for collaborative robot, which means that it does one of, I think there's 4 ways to be collaborative. And UR does power and force limiting. So they monitor all of the joints for their current draw and make sure that it's drawing the expected amount of current. And, when we bump into stuff and, send that current outside of the accepted limits, then it becomes a protective stop. And I could go on all day about collaborative robots, but I transitioned into a company now that integrates UR arms. And I'm working under a gentleman named Greg McIntyre that I worked with in a past life where we were integrating not only robots, but vision systems as well. Mm-hmm. So anytime I get a chance to give a robot eyes, I love to do that. I've run around to, other people who are obviously very educated on the robot itself and understand the robot system. And I love to run in there and say, but can it see what it's doing? Can we do more with it? Can it articulate more? Can we do more complicated tasks? And I got to do a lot of that previously. Now I get to do more of it with a larger line card. I'm at United Robotics Group, so we not only integrate Universal Robots arms and have the intelligence to make sure we get vision in there somewhere. We also have a company called Robotnik that we acquired out of Spain that sells AMRs. And there's solutions including AMRs with robot arms on top of them. And there's also just some really cool AMRs that have instrumentation on them so that they can maybe drive around. Say, in my mind, I went to the tank farm at a refinery because that's kind of where I came into automation in the very beginning. The tank farm guys spend 8 hours a day in their truck, kind of going around taking readings. And I don't want to oversimplify the job, but I think a lot of that time is spent just getting, from reading to reading, where an AMR could, run around and gather sensor data or camera data and report back to you instead of, you having to get there in your truck and burn a bunch of gas all day. So that's
you can collect that data remotely. Like, can you collect it wireless, or it requires a robot?
It would be a wireless connection. I have yet to actually get to implement one here in the States, but we have a lot of deployments that exist in Europe. So one of the fun things about this company that I've started is we're a wholly owned US subsidiary of a company that exists already in Europe and owns 9 or 10 other robotic startup companies not all startups, but companies that are in various stages of existence, from startup to, Robotnik's been around, I think, for, more than a decade, creating AMRs. But in the US market, we have to kind of introduce some of these products as just United Robotics Group, whether you know these European companies individually or not. I'm kind of trying to just unify everything and represent them as United Robotics Group. But there's just a larger line card that I'm used to being able to work with, because there's also a whole set of hospitality robots that are amazing, cool. I love watching them go. I just can't talk at length about them because it's just not my industry. But they also sell a robot called Play-Doh, which is in restaurants and kind of brings out your food with the waiter. So it doesn't replace the waiter, to my knowledge. They still kind of come out and take your order, but they help bring the food and make your waiters less upset about having to come out and do this like juggling act with, the 27 plates that I see them doing sometimes. I don't know the restaurant industry very well, so I like the robots and everything, and I think they're cool, but it's just not an industry that I understand. They also can serve in like hotels, maybe these things can bring your sheets, or the linens back and forth. There's use for them in casinos. It's just they're the things we can use robots to do now. The list has grown, and I try to stick with the stuff that I know, which is just industrial manufacturing in general. But our company has a line card that can serve like all kinds of stuff that I don't know, and it scares me, and that's always exciting for me. It's intimidating, and I don't know what the answer is. So I stick in my lane, but we have like a whole chunk of sales guys and specialists on the hospitality side as well.
No, those are all like very interesting applications. I will also say that I'm certainly not an expert in a lot of those verticals, but I think it's interesting to see how even some of these, I want to say, industrial like applications drive maybe adoption in other fields, right? Because I think we've had AMRs for a very long time, and I'm very certain that the companies that manufacture those robots for, like restaurant or hospitality applications have probably looked at, the data, how it's done in manufacturing, how it's been like performing in order to kind of make it more accessible, I want to say, to those industries. Dave, what are your thoughts?
Yeah.
Sorry.
No, I was going to say,
I want to know
I think that this is this is a really interesting. A couple of housekeeping points. Courtney mentioned Greg McIntyre, episode 84, on manufacturing hub. We had him on I think it was like right before Universal Robotics Group, what was announced as a name, or perhaps directly after Universal Robotics Group, what was announced as a name. And we talked a bunch about vision systems. So I thought that was very interesting. Greg is absolutely the artist on the vision system side that I am most certainly not. And I know Courtney also very much kind of that artist on the vision system side. But no, I think that's really interesting. Courtney, I know that you've got a bunch of fun applications and other things that you've done on the industrial side. Do you perhaps have an application or two that you could go share that are some of the either your most favorite or perhaps most memorable that you can talk about?
Sure. I'll say the most memorable one that I go back to talking about is memorable for a lot of reasons, not just because it was my first time really making vision guided robotics, like making an application that uses both, but really just everything that went wrong in this project and still being able to deliver by the end was an automated cosmetic inspection system. And we were taking product off of the conveyor and doing like a multi-sided inspection of this thing. And not just like, if you imagine a cube, not just the 6 sides of the cube, but each side from a few different angles so that you can actually highlight, like if I'm looking at my phone and I want to see if there's a scratch, on the screen, I can hold it at a few different angles really. And you can see I'm reflecting light there, but, catch a scratch at a different angle. So you don't just want one picture of the one side. You're actually kind of, getting, I think we got 14 or 15 pictures out of this inspection, looking for different stuff on each side. But we had to tie into the customer's ERP system and kind of, report back what we found and where the thing was supposed to be going next. And, the funnest part about it was during the delivery process, we had two robot cell for multiple lines. I think it was 3 total, but that's 6 robots in a 2 robot cell configuration 3 times. And we had 2 of the robots arrive, one in one cell and one in another cell, with the teach pendants sheared off because of some packaging issues. And that rendered us dead stick on those robots because we didn't have a backup plan for the teach pendants not being there. So we ended up at that time installing the good robot from one cell and pulling the bad robot out of another cell. Basically, like we had a good left and a good right out of the 2 of the systems and getting 2 out of the 3 lines running while we waited for UPS Red to get us replacement teach pendants for these ones that were down. But everything said and done with this customer, we were ultimately, by the end of our trip, picking up this box, doing a multi-sided inspection, deciding if it was good or bad, and putting it back down. It sounds really straightforward, but there was a lot to it, and everything going wrong, I feel like kind of forged us in fire. So I always kind of bring that one up as the you learn more from things going wrong than you do from them going right.
I would say that that doesn't sound too straightforward. I don't know. For me, vision applications are always more art than they are science. And if anything, like personally, I get frustrated by anything that's not fully, like fixated in place, which I think a lot of the industrial applications are. But as soon as you get that like motion involved and then you have to get feedback from the robot, I could see how it can get complex really quickly. So.
Yep.
Absolutely. Well, let me ask
another fun one.
I was going to say, can I ask a question on that? For myself, who is not super familiar with UR teach pendants, and for all of our guests. So you were saying that the teach pendants were ripped off of particular robots. Would it be possible to take other teach pendants and go through the teaching process on the robots that you were missing the teach pendants of? I guess, is that possible? Are teach pendants directly for each robot and they are not interchangeable? How does that work?
So on the current robots, like their Gen 5 robots, the teach pendants are pretty easy to unplug and swap. I think I was working on the Gen 3 robots, which the teach pendants you could pull out of the control box, but it involved one connector that was kind of painful to access when the controller was installed where it was installed. So what we ended up doing was swapping the entire controller instead of trying to disconnect the connections from the teach pendant. So nowadays, like if I was to do this whole project over again and it was happening with the Gen 5 robots, I would unplug the teach pendant because it's actually a fairly easy to access single connection. And on the older robots, they were actually broken out into, the video and the e-stop and the, some other stuff. I won't go into too much detail on it, but it wasn't a single connection. There was multiple connections to undo.
There's a few, I was going to bring up, there's a few good comments in the chat section. So Kai is making a joke about having a robot load a dishwasher and put the dishwasher and the dishes into the right cupboards, which I think I want to follow up with a question, on the robots plus vision system side. How do you evaluate if an application is going to be feasible, right? Because I think that you definitely need to take care of the vision system as well as integrate that into a robot. And as you mentioned, there's, multiple angles. Do you have to get the product from the customer and then maybe run some tests in the lab? How would you approach maybe evaluating the feasibility before you commit to, let's call it, building a full machine for the end user?
So the two things that I'll typically look for are, first and foremost, is it even physically possible for a robot and a vision system to do? Can the vision system even see it and resolve it? And can the robot reach it and pick it up? If you can't get past that part of the conversation, it's dead in the water. That being said, that's usually not the limitation, because with enough time and money, you can pretty much automate anything, in my opinion. But you're going to run into a limitation on either time or money before you get there. So is the customer's budget reflective of the hardware, and not just the hardware, but the labor that's going to go behind this project? The number of times I've seen customers who are dead set on spending as little as possible on the hardware just don't have the budget for the labor that's going to need to follow. Or what they want to be able to do as much as they can, and then create limits. I don't want to say artificial limits, but limit the application in such a way that it would cost too much money to really be feasible. So generally speaking, vision, first thing I'm going to check is how big a space are you trying to see, and how small thing are you trying to resolve. If you want to see this super tiny pin in a 2 foot by 2 foot rectangle, you're going to need a resolution that doesn't exist, or you're going to need to put 17 cameras on that to be able to actually, see your part. The other one with robotics is how heavy a part do you have, and what variance in weights are we actually looking at? Because some customers have, they want to run 8 SKUs, and they range from 3 grams to 97 kilograms, and you're like, well, I can't pick up the huge one, but I can pick up the tiny ones. I can pick up 80% of your products if you limit me to this section here. So, and the reach of the cell. Most of the time, if you can't get the reach out of the cell, you could put in external axes or offset your payload a little bit, but it just comes down to physical limitations and money. Can I fit the 7th axis in there? And do you want to spend money on a 7th axis?
I think that definitely makes sense. I like those examples, on the scope of the project to be defined. Again, my experience has shown that a lot of it is to some extent winged in the field, right? And you need to almost kind of test different things before you see what works. And it's I don't know, again, I have maybe some PTSD with vision system applications, because I know how difficult they are, in a lab versus going to a plant. And I think it induces even more variability, which is a good question actually from Phil. So Phil is asking, how much work does it take to teach the vision system to catch everything you needed to. And so I think this is a, if you've not experienced vision systems and you're maybe listening to us talk, I think there's a huge, again, like once you show up to the site and you probably have a lot of thoughts on how it's going to go, you have to tweak the system before it actually works on a real line. So maybe I'm curious on your perspective, Courtney, what did that process look like, maybe in this project or just in general?
So the lab is always going to have more controlled settings than your production line. So we have control over, the wavelength of light and the volume of light, is kind of the big one. Trade shows to me are always kind of the hilarious thing, because whatever you came up with, the trade show lighting is going to be obnoxious. It's so much brighter than anything you accounted for. Customers have done silly things like install their line right under a skylight. So they tell me it works at 10 a.m., but not 2 p.m. because the sun was over there versus over there. So that's, lighting, I think, is the number one challenge of lab versus real life. The teaching defects is interesting because all of the work I know how to do up until this point in traditional vision systems is kind of going away, because I think machine learning, at least with vision systems, vision systems are ripe for machine learning, because you just basically have a matrix of data, a whole bunch of pixels that you've either got, 3 pixels because you're dealing with color, or you got 1 pixel, it's black and white, and you just, how black or how white is it? And then the system can learn, little areas of interest all by itself, which to me is mind-blowing for things like textile and let's just say fruits. One of the projects I remember no bidding on was strawberries, because it's easy enough to tell an operator, take out the yucky ones. Okay, so how do I tell the computer if yucky, remove? What makes it yucky? How green is it? How big is it? How do you quantify or qualify what makes something, just as a human, sometimes you appreciate what we're able to do without thinking about it very much. Like, I don't have to think about what's a yucky strawberry. I use my 5 senses and I reach for the strawberry. And if I don't want it, I don't eat it, because my brain just kind of knows how to evaluate that. We're trying to teach cameras to do the same thing, because I can't, with traditional machine vision, tell you what makes a good strawberry. It's too highly variable. That's something Greg always called a God product. It comes out the way God made it. You don't have a spec sheet for it. It's just going to be highly variable. And deep learning systems can just kind of, group together what makes a good. And I'm not necessarily going to know or agree with what the system identifies as, the qualities that make it good. But if you give it enough examples of good and enough examples of bad, I don't need to actually do the programming of highlighting a region of interest and specifying a color threshold and all kinds of stuff that, traditional vision calls for. It's like a lot of that stuff now, we're just going to let the system figure out what made it good or what made it bad. But you have to be good at training it. That's the other thing, is your quality of data is going to have a huge effect on, the quality of the model that you train. If you actually give it 100 pictures of actually good and 100 pictures of actually bad, it'll learn. I've seen, a few people have to go back through and be like, oh, I accidentally flagged this thing as good or bad. And then the even scarier thing was the system was like, are you sure? Because it looks like a bad to me. And you're like, oh, dang it. You're right, computer. It was a bad one. I concede.
I've not experienced those kinds of vision systems. I've worked a lot on the traditional ones. So I'm really curious where that kind of threshold lies, right? And the example of strawberries, I think it's very interesting because there's such a, I want to say a wide range that is very close to being good and bad. So I wouldn't know to what degree it will reject, let's say, the good ones, and then let's say keep the bad ones still in the batch. It's very interesting. And again, maybe there's some statistical analysis on that, and I'm sure the systems will and are getting better, but again, it's very interesting.
Yeah, I think that supervised learning concept, if you give it some gray area stuff and, teach it, which one was good and which one was bad.
Dave, what are your thoughts?
Absolutely. I think it's interesting, and I think that the strawberry is very difficult, as Courtney mentioned. I looked at I looked at a much easier version of what would have been a vision a computer a machine vision system that we could have used AI or ML on. I, as most listeners heard, I spent some time working with a co-packer. They did cans, right? So they canned a bunch of things, and these guys were interesting because they ran almost exclusively very short runs of things because that's where they were in the co-packer. So instead of having printed cans like we see in the store, they had heat shrink wrap labels that go on the cans. So they had this wild machine that I've seen in no other canning facilities. If you guys know, like the Aquafina water bottles, right? So there is a layer that has the label, and you can like pick at the top or the bottom of it, and it is basically the exact same thing, only it wasn't designed or run quite as well to be able to do that. So there was a lot of manual visual inspection, and every time they went to go run something different, it was all of those manual tweaks. And so for me, it was a prime opportunity to go run 1,000 or 100,000 of these pictures through and make sure it's not too high, to make sure it's not too low, to make sure that the steam didn't kind of ripple or rumple anything a little bit too much. And then every time they changed these roles, it was a opportunity and application to basically, we've got to go refigure out how to run this brand new role now that we've just figured out how to run the previous role. It was a wildly inefficient process, but I think that's the opposite of the strawberry. That's we should be able to very easily and very quickly understand if we're running good cans and sleeves within the cans, or other parts of kind of any system like that. So for me, and Phil down here in the comments had made a similar question, basically asking how close do you think the vision industry is to being able to leverage that AI or ML? And so for me, going and looking at a bunch of opportunities, I think that is fairly accessible technology that we'll see more and more people using. Do you also imagine that we will see more and more of that for quality and for other things into the future, Courtney?
I do. I think that for just robotics and automation in general, and I lump vision into that, we like to take away things that are dirty, dull, and dangerous from people. And vision, like visual inspection, can be, you can find a way to make anything exciting, really, but I think it's a very dull task and so easy to just go snowblind after a while. Like if my job is to just pick this thing up and check it for defects all the time, it's just pink thing, pink blob, pink blob, pink blob. And even I remember somebody telling me this statistic, but it was something like even at, your best operator on, an 8 hours of sleep and a full pot of coffee, just their top performance is still really only going to do that job well for 20 or 30 minutes before they really just start to kind of let stuff go, because it all looks the same. I call it snow blinds, but after a while, you're not going to see defects because it's all just going to become blurry and kind of mindless. So that kind of work, I don't think is well suited for humans to do anymore. And really, the companies that are doing it now, I think, are still kind of bigger players. But my bigger question would be is how much is a rejected lot cost you? Because I think that's really where the payback is. You stop one rejected lot, that could be, for a company that's, say, making roofing, and they've got a whole bunch of, trainfuls of gravel coming up. For whatever reason, you reject an entire train load of stuff. I can only imagine that costs hundreds of thousands of dollars, if not millions. So one rejected lot there is extremely expensive versus, say, a company that's making small batch custom stuff, and one rejected lot, isn't that big of a deal. Mm-hmm. So I'm gonna say that's kind of where the line is. I don't know what the cost of these systems are anymore, because it's been a while since I've had to include something smart in a vision inspection. Lately, all I seem to be using vision for is landmark detection, which is kind of funny to me because we're capable of doing so much more with it, but all we really want to know is, how far off does the robot need to adjust its position right now?
Yeah, and I do want to get into that discussion. I think that's a really interesting application. We talked a little bit off stream about that, but again, I think like to close off that AI ML side of like vision systems, I think pretty much like every vendor has some kind of a flavor of such a
Mhm.
camera, right? So I know for a fact like Cognex, Keyence has it, if I'm not
Yep.
mistaken, like BNR camera. So I think the industry is certainly moving in that direction. And again, I don't have a full grasp of like how precise or accurate those are, but I think they're certainly making it more accessible and easier to evaluate for those applications. And I think maybe to Phil's point, it's not that you save money on just the hardware, it's also, the time, as we discussed a little bit earlier, that it takes to dial in that application, right? So you might be investing a bit more on the hardware and software side, but you're saving on the hours it takes to program and dial that in, right? So I think it's important to keep that in mind as well. Dave?
I was going to say before we transition out of the industrial side into the AMR, Miguel had a question talking about have you used robots in medical or medical center applications, and that's a conversation Courtney and I have never had, so I don't know what the answer is, but want to give Courtney the opportunity to talk about if she's done that in the past.
So I personally have not. However, I am aware of our company is based in Germany, our parent company, and they do have some installation in medical environments, specifically our U Mobile lab. I cannot tell you how many installations there are, to be honest, but they have been in use, I believe, in German hospitals. So the handling of vials of blood, more or less. What happens to them after that, when they need to go to and from different parts of the lab and, get loaded into and out of automated chemistry machines. So that's an industry that's super fascinating to me because I'm not great at chemistry. Flunked it twice actually trying to get my degree. That's why my GPA and my bachelor's was so low because I kept not passing chemistry. However, I don't need to understand chemistry for those applications because all those machines are incredibly sophisticated and you just need to give it, the vial and it does the chemistry by itself. So, can I make a robot load and unload that machine? I can do that all day. What that machine does is highly specialized, and it's insane. And I think that's another industry that could probably benefit from you know the tedious work of loading and unloading vials of blood, where the person that you hired to be good at chemistry, can be good at chemistry, is a field where we'll see that growing quite a bit.
Absolutely. I will say so. So when I was in Hanover earlier this year, I found this super cool startup, and very much kind of attached to the medical and the medical labs. So most of the places that I go to, like if I'm in a hospital or if I'm in a urgent care or something like that, which happens about once every 3 or 4 years, it's they have the ability to go run those tests on site. From what I'm being told, in lots of places in Europe and Germany, there are a couple of central labs, and most of the places, even like regional hospitals, don't have the ability to go run tests themselves. So historically, they've gone and sent couriers or cars or something like this. I found this very interesting startup that the concept was basically you load the vials into a tray, and it's got like this, it's got this device that has tracks on it that basically rolls it outside onto a drone, and it loads it into a drone, and then it just goes and flies home. And home is the center lab. And apparently they are very new, but they had a couple. They had some number of applications, and I think they had like 2 or 3 kilos worth of payload, so like 5 or 6 pounds worth of payload from what they were saying. I thought that that was a very interesting application. That while I don't necessarily see it working in most of the United States, between the fact that we've got lots more labs and lots more people good with chemistry, and most places that don't have labs are probably outside of a drone range. I think it's a very
Right.
interesting concept and solution to a problem that I wouldn't have ever considered. So thank you to Miguel for that question. Before we go move to AMRs, we've got some people to thank. So we want to thank Solus PLC for sponsoring this robotics theme. If you're an engineer or a technician looking to break into industrial automation or upskill, Solus PLC is your go-to resource. They've got these super in-depth tutorials and online courses that cover all of the nitty-gritty, from PLC basics to HMIs and even robotics. And the best part, you're learning from people who actually do the stuff for a living. No textbook nonsense, just real-world skills you can use. Thousands of students from companies like General Mills, Amazon, and Tesla are already getting ahead with Solus PLC. So whether you're a pro or just getting your feet wet, there's something for you. So what are you waiting for? Head over to solusplc.com to get learning. So we'd like to thank Vlad and Solus PLC for going and putting together this, helping us put together this robotics theme. And I'm going to say, if you guys are interested in robotics and a little bit more about who's teaching those robotics courses, we had Pavel on episode 133, and that was an awesome conversation. I feel like we've got so many awesome conversations in robotics that we could probably just become a robotics podcast. And honestly, if Vlad and I had like any idea of how to do robotics, that might just have been what Manufacturing Hub becomes. But Courtney, can you tell us a little bit more about maybe what AMRs are in general and how you guys are using them, please?
Yeah, absolutely. AMR is an autonomous mobile robot. So that definition actually can encompass quite a few things. There's a committee for ASTM for legged robots. And I'm not sitting on that committee, but they had a meeting this morning and I was invited to sit in on it. And while I didn't actually join the meeting, I got to see the chat messages popping up, which is very interesting stuff going on in the legged robots community. The ones that I focus on have wheels. There's a product line, if you guys want to see them in action, it's a company called Robotic. Literally like if you remember Sonic the Hedgehog, the orange mustache guy, Robotnik, like the name of the company is Robotic. Look them up. They've got really cool solutions for like indoor and outdoor. The ones that I've worked with so far are the one called the Theron, which is similar in size and shape to, say, a mirror. And I believe similar in payload. This is where I'm going to start to get into the weeds because I'm kind of new to AMRs. But I believe the payloads are 250 kg on those ones. And yeah, they can haul around quite a bit. The one that I've been playing with has like a little elevator unit on it. So it can drive like underneath a cart and then the elevator will raise it up, say an inch so that it's off its wheels. And then you can drive it off wherever, or off its feet. And you can drive it to a new location. That one, I believe, is 150 kg. But if you have less than 150 kg worth of parts on a rack, then you can take the entire rack with you, which is kind of a cool thing I've watched happen in warehouses and places where they're doing like small parts assembly. So if the tray of parts and everything on your rack is under 150 kg, you can literally just bring the whole parts tray over to a new table. The other thing that I've seen that I thought was kind of cool is it has I think they're called Mechanism wheels or Swedish wheels, but they're like the omnidirectional wheels where like you can kind of see it like going diagonally all the way around. And it kind of can like, it almost looks like it's hovering the way it can glide around. Those ones, they can turn like really, really tight radii. So the car can basically pivot around its own center and turn around. We had a demo in our Automate booth this year where that Theron was in a little hallway that's just stupid tight for it. And it had maybe an inch, on either side really to kind of get itself turned around. And it just did that and went back and forth all day, never hit the wall, which I thought was pretty interesting. Another one called the Vogie, which is enormous, and I don't know its payload off the top of my head, but can hold a significant payload and also has a solution with a manipulator arm on it. So I've seen, I haven't seen what actual deployments are using this right now, but my imagination goes kind of crazy with it. I can imagine a lot of like supply chain logistics problems, warehouse stuff, kitting up, making parts kits for somebody, all kinds of stuff I could imagine doing with a mobile manipulator arm. And
Courtney,
then one called, yeah, go ahead.
Sorry,
I
I was
can go on
gonna
all day.
no, I was gonna throw in a question. I guess like as soon as you
Yeah.
introduce an arm on top of an AMR, right? Like you need to be able to locate fairly precisely because in industrial applications, that arm is fixed either to a very fixed point on the floor or it's on an axis
Yes.
that can move extremely precisely. So at that point, you need a vision system to be able to see what the robot is. That always the case? Are there applications where it's just an arm on an AMR? Or how do those maybe three things, vision, arm, and AMR, like fit together in your perspective?
So the only way I could see it working without a vision system is if there was some kind of like ball-ended tow hitch type thing that the AMR would drive into, and then that piece would kind of center it as it drove forward. Otherwise, the repeatability, to my knowledge of AMRs, is not quite what it is on a 6-axis robot arm. So you're going to park within, instead of say a millimeter tolerance, more like a centimeter or inch type tolerance. And as long as you have some kind of landmark, which if you haven't, if you're not familiar with the term, we kind of use as a known pattern that the camera can recognize in an image and say, okay, I found it here, and I'm going to create a coordinate system with that as 0, 0. More or less. So as long as you can get the landmark in your environment into the shot for the camera, and as long as, obviously the manipulator is within reach of whatever you're trying to get, you can correct your position based on the landmark location. So that's kind of that's my knowledge of how people have been doing it, is you have a recognizable pattern that the AMR can park close enough to that, the arm can get the landmark in the shot and do its position correction based off of that image.
What kind of like tooling exists today to sort of like fit all of that together, right? So again, in mine, like I know how Cognex cameras are programmed in general, and I've seen UR robots on the floor. Is there like a function that you drag in, like, hey, here's the landmark, and it's gonna automatically perform that correction, or is that completely custom code that you need to like come in and write so that it adjusts that field of view? Like, what does it look like for an engineer to step into that environment, and how easy it is to make that link between vision, arm, and ultimately the, I want to say, like rough positioning of the AMR?
So I can talk at length like on the stationary robot aspect of that, because we did that for many years. You just have I think it's called eye in hand, but you take your pictures with the stationary robot and do corrections based on, say, a nest moving or what have you. And the tools with respect to that are going to be the same as if you parked and then ran all the tools. Like, you're treating the robot like now it's stationary because we're not going to be driving and manipulating at the same time. I'm sure there are cases where we'd want to do that, but really it doesn't make sense to me to be both driving and trying to manipulate, unless maybe you're like trying to stir your coffee while you're going back to the office. But doing a correction after you've parked is going to look, to me, the same in the vision system as if you were just stationary to begin with. And you're going to correct for wherever you find the thing that you're looking for in the image. You're going to perform a correction with where is that tool in space and where I'm seeing this landmark versus where the robot's base coordinate system is 0, 0. So that's almost always going to have not just like an XYZ shift with it, but also an orientation shift. So it's not going to be at exactly the same angle unless you're really lucky and you've parked like perfectly parallel to your conveyor, or like a list of stars aligning. That usually doesn't happen. So you've got, not just like XYZ in space, but if you've got your right hand rule, how is this coordinate frame, oriented with respect to your base system? I'm doing a left-hand rule because I only have 2 hands, but I have a base coordinate system and some other coordinate system that is offset and twisted. So the camera can see, like a 2D camera can see 3 portions of that. Like I can see X, Y, right? I don't know how, deep I am without doing other calculations, which is going to be a Z height, but I can get where am I and, a Z rotation. And a lot of times what I'm doing is looking at a conveyor. So that's all I really need is the conveyor height shouldn't change on me unless I'm dealing with a slanted conveyor. So I keep my Z height fixed and I say, where is my X and Y and how far away is that? And a lot of robots have functions built in for doing that. So an example with Universal Robots is they have a pose trans function. So you would say this coordinate is, the one that I'm caring about, and this is the one that I'm transforming it to. So, if I have a camera system that's away from the base, that I'm saying I'm transforming this point into the coordinate system of that camera point. So you don't have to do, I think it's like a page worth of math for doing all of those offsets. The function will actually just spit out a new coordinate at you and say, if you're going to go to coordinate with respect to this system, then just go to this coordinate. And if you're going to do something with a mobile robot, that's where I'd actually say, now I get to be an integrator and say you want to have an integrator come do that, because there's not a lot of companies I'm aware of that have made software that not only tie in the correction of the position of the thing with respect to the arm, but also to tell the AMR to go park in a specific location. So that's something in a UR cap or like a driver that we install that we've developed called Yugo. Our company Robe Solutions developed that. So you can actually tell the AMR which positions to remember and then create tasks. So you say, I want the AMR to go to this position and then call this robot program.
Interesting. Yeah, I can imagine there needs to be some kind of like no problem. There must be like some kind of an orchestrator, right? That like again like glues or integrates all of those pieces and like maintains some kind of a register, maybe of position of the robot and what's the vision systems doing, what's the arm doing, right? There's a lot of moving components. It's really fascinating. I think you explained it maybe in an easy way. I'm sure that it takes a lot more effort to make those applications happen, and a lot of disciplines go into that, which, maybe let me ask you a slightly tangential question, but I think it's relevant to our earlier conversation. If someone is excited about robotics, is looking to maybe upskill themselves and learn more, what's maybe, I guess I don't want to say like what's a good discipline, right? Because then it becomes like electrical, mechanical process, but maybe what are some good resources that they can, I know like UR has some kind of an academy, I think that they publish. I think that you can certainly learn robotics, but if you want to do these sort of like multi-discipline applications, what could be like a good path for someone to take who's maybe, still in high school and is considering programs, maybe university, maybe trade school? Any thoughts on that?
Yeah, I think one of the disciplines will almost always interest us a little bit more than the others because all of them are important. You can't just be purely electrical or mechanical anymore, I think, if you want to do robotics, because they both make the robot go. So, in my case, I drifted towards electrical. That's what I studied. So how did I focus on the shortcomings for mechanical? I downloaded the CAD and I started trying to design some stuff myself. So I'm not great at SolidWorks. We joke about at our company SolidWorks glue because we forgot to design in the hardware and parts are just kind of floating in space. And we're like, it's mated. Those just magically stick together. But, just learning the side that I'm not good at, just trying to design some projects, even if they weren't real, getting something under my belt that was a little bit more practical. And I think if you're on the other side and you drift more towards mechanical, grabbing the CAD for electrical and drawing up a schematic, because these are 30-day trials you can usually grab just to teach yourself something. So I'm all about free trials of stuff. And that's where I've gotten a lot of my education. So like if I wanted to learn controls, 30-day trial of, I think the Automation Direct software was one place where I kind of learned how to just coils and contacts and PLC stuff. And then another one that I recently taught myself that I thought was fun was RoboDK, and just being able to like animate a cell and do a proof of concept. So another thing where I just tried to grab free trials and do what I can in 30 days.
I think that's very interesting. I am going to come back to RoboDK and the simulation question, Courtney. But first, I would just like to draw to the attention for all longtime listeners the completely different direction that Vlad and I go. Vlad was super excited to go ask about mounting arms and all of these things on these AMRs, and my first thought was, I really want to go ride one, right? Like it's got a couple hundred kilo pay limit. Where can I go? Who has one of these AMRs that I can just go get video of myself surfing on one of these things? Because I think that would be a lot of fun. Probably innumerable safety violations. I will say, Vlad and I will be at SPS Nuremberg. If you've got an AMR that's got a high enough payload for Vlad and I, almost exclusively separately, to go get video of us going ride these things, please let me know. I now have another bucket list thing of something that we've got to do the next time we go to Germany, Vlad. So one, thank you so much for that, Courtney. I could not complete this thought of the AMRs without that. I do want to go back to RoboDK and simulation. We've had a couple of conversations about simulation. I guess we've had a number of conversations about simulation. We've had a couple of conversations about robotic simulation. I guess overall, I'd like to get kind of your perspective on it. And outside of just that overall perspective, I'd like to know, is it a helpful tool when you go talk to customers to help visualize their process? I think that is kind of the burning question on my side.
Yeah, so being able to animate a cell and show a customer what the process would look like is a very powerful selling tool. I have found that, a 10-second video of a real, like if I had the right size robot for a customer's application and they happen to send me parts, a 10-second video of the thing actually dealing with that part is more like, I got more out of that really than other things that I've tried. In RoboDK, in the past, what I've been able to do is import some rudimentary, draw up some rudimentary shapes and kind of show something that looks similar. I think there's ways to import CAD models into RoboDK, but I didn't get to dig all that deep with it. But, you can even generate, like after you've kind of grabbed the robot and animated it, you can select the robot that you're really using and generate code, which is kind of cool. I don't know that, it's 100% perfect, that you don't have to go in and like make a couple of changes, but that on the, not just as a sales tool, but as a, as an engineering tool is kind of useful, because maybe you do exactly the same robot cell for another customer and they didn't want to buy that robot arm, they wanted to buy this one, and being able to kind of swap out that robot and generate the code again is extremely useful as far as saving time. And then I want to see, and I don't know how far we are away from this, being able to simulate like a customer's plant floor and put the AMR in there along with the robot arm and vision, because I'm not aware of the ability to there's a lot of things where I know I can import a customer environment and then, throw in the CAD model of the robot, but I want to be able to actually like path plan and drive a robot like around a facility. And maybe MATLAB or something like very academic could probably do that. But if anybody's aware of a software that can do that, I'd be interested in using that as a sales tool as well.
That was going to be my follow-up question, actually. I don't think I'm aware of a tool that does both of those at once, right? My thought would be that you would need to simulate the AMR, obviously like where it stands, and then it's almost like a standalone like pedestal at that point of like an arm like moving objects. But yeah, it's interesting if there's a possibility, because ultimately that robot could be attending multiple stations, right? So it wouldn't be representative of a like fixed location. So that's interesting.
I I don't know if it's Siemens Plant Sim or Process Sim. I know that we've seen much of those simulated the last time we were at Automate with them, and I know it exists, and I know that they can go simulate the robotic arms. I'm just not sure about the AMRs because honestly, I was not paying that much attention to any possibility of AMRs while they were there. But I would say we can certainly reach out to some of the Siemens Simulate folks that we know to see if we can do both like robotic arms as well as AMRs. I think that that would be interesting. And to your point, Courtney, I think it's an interesting sales tool as you go through robotics. I think seeing is believing, and that's kind of what I say
Yeah.
over and over again. And I can do a pretty good job of visualizing what the end outcome of any project is going to be. But short of grabbing a crayon and drawing on a whiteboard, what I think that's going to look like, and I am a terrible artist when it comes to that. Uh, but I think that going and being able to simulate that is very interesting. And anyone who has listened to me knows that I'm like super excited to go see more of these simulation tools become more mainstream, so that eventually I get the chance to go use it with clients. And then we have someone talking that there is a it's restricted on here, but they're saying Technomatic. I think maybe Technomatic as a potential tool to allow us to do that. No, interesting. So this has been very exciting. Yeah, this has been very exciting. Courtney, we want to go ask you kind of all of the questions that we ask everyone. And I have prepared you for this, right? So one of my most fun questions
Yes.
that I get to ask everyone is I get to ask you to predict the future. And luckily, I'm only asking you to predict the future of robotics, which, as I told you, there is almost only wrong answers because what we imagine is probably going to be far surpassed in the next 5 years. But Courtney, what do you imagine the future of robotics looks like?
So I've been very entertained by the amount of data that everything wants nowadays. I think, I mean, I'm not like opposed to it or anything. I just think we have so many things spitting out data that, I'm always wondering, like, how good is this data that we're collecting massive amounts of? But I don't think robotics is going to be any different than everything else. So IO-Link has taught us that we want all kinds of information about our sensors and sensor health, and just having everything you could possibly want to know about a device sitting in a register somewhere for me to access and display or manipulate if I want. And I can see robots being just as connected as any of our smart devices at home. So when we come home and we want Alexa to tell us everything about the weather and our house and set the light temperature to exactly the right color and the house temperature to exactly right, we're going to have robots that are learning, kind of on their own, the exact right configuration that they need for the next run that's going to happen. They're going to report back to their machines what's going on when they need maintenance. I think there's just going to be a lot of data-driven stuff happening in robotics. And I think it's going to start reflecting what our smart homes look like. So we're going to have, some centralized commander that we're like, Alexa, run recipe 7, and your factory is going to respond appropriately. Now, is it going to be 100%? No, but a lot of times I come home and I tell Alexa to turn the lights on, and one of the lights is misbehaving and I have to go, turn it off and turn it back on. So I think we're going to see a similar evolution in manufacturing.
Interesting. I think that would be a very exciting evolution, and it'll be interesting to see how people behave, especially when we go ask Plant Alexa to go turn all the lights on or to go turn line 3 on, and everything works except one conveyor belt is jammed or it's extra sticky because we didn't clean it last night. And what happens when we do that? Will it become just the norm, or will there be some people who don't accept that, and will it go drive those solutions to a higher level or a higher SLA? So I think that'll be very interesting. Next question for you, Courtney, is I'd like to go ask for some career advice, and I know you gave us some interesting advice in regards to college versus trade school versus going and learning on your own. And I think that that's really valuable. I think some of the best dollars I ever spent was to go to trade school. And I think some of the best things I've ever learned is when I really wanted to go learn something and went to figure it out myself. I think that the people who do that are fairly prevalent in this industry, but in general, I think that they're generally far and few between who are going to go out and go kind of figure everything out themselves. But kind of speaking of that, if we've got someone looking to get into especially robotics, or looking kind of mid-career, maybe looking to make the shift into robotics, what is your best career advice for them?
So to what I was saying before, making sure that whatever it is that you want to invest in, making sure that it's actually like being clear on what you're going to get out of it, is like the number one first step. But I would always say go try to find in your community, workshops, because I'm seeing more and more of that now. I'm even part of it myself in California. It's trying to organize, tech workshops with students, because we want to show off our tech to students who are, going to go to college and choose their career paths. So, that's something that I know we're not the only company doing. So there's, depending on what your region is or who's really active in your region, some areas might have like where I am, we have ATC, which is like advanced technology consultants, but they sell hardware and curriculum into technical schools. And, I know that they have, UR and Festo. And I don't know that that's the same all over well enough to say that if I wanted to learn, something regarding Festo or UR, there's locations here where I can go put my hands on real hardware as part of a workshop without spending any money. And I would say, if you know people, especially in the LinkedIn community, that are in or near your region, reach out to them and find out, like, where are these free workshops going on? They're usually like a 4-hour, a half-day workshop here or there where you get to actually go touch real hardware.
Absolutely. I think that is great advice. I'm going to take a moment before asking the next question. And Hank and the junior board of directors are in the chat, and it's the junior member of the junior board of directors' birthday. So we certainly want to wish her a happy birthday. Always happy when Hank and the girls can make it on. So thank you guys. And then System Restored commented Technomatics, and then a link to a Siemens Technomatics. I was correct. Siemens had a simulation solution. I was just incorrect as to the name of the Siemens solution, which, if anyone knows me, will know that is completely par for the course. So thank you to everyone on that. Courtney, I know you've got a book recommendation, or perhaps a couple of book recommendations for us.
Yeah, absolutely. So the one that I most recently read, and it reread actually because it was so good, I read it twice, was James Clear, Atomic Habits. And really the concept of, well, for me, I'm the type of person that when I set goals, like I set my goal is go conquer Russia, and I'm like, that's not an attainable or realistic goal, right? So his concept of, like, really like the smallest possible changes that you can make throughout the day, being really like where the value is, has really kind of like, there's a lot of stuff that you'll read in that book that you're like, well, duh. But he puts it in such a way that you're like, well, no, I mean, I'm guilty as sin of not attempting something unless I can do like the really big thing or the whole thing, and being able to set habits and just say the thing itself is not your goal. It's the habits that lead up to the thing that are really the goal. So changing the habits and changing the process, is really what changes the result. So it's like, don't change the result, change the process that leads to the result. So that's a book I really enjoyed. There's another one called Tao of the Side Hustle. And Automation Ladies actually got to interview the author of that book because I reached out to him and he was just a really cool guy. His name's Don Kilbasa. And he is also he's the motion capture actor for the Mortal Kombat video games. So he wrote a whole book on, it's called Tao of the Side Hustle. And I thought it was interesting because I am Buddhist. I am a chronic side hustler, and I'm also a martial artist. And he kind of incorporates all of those things into one kind of set of instructions for like optimizing your side hustle. And it's a very good read, and I highly recommend it. Yeah.
I like that.
Interesting.
I'm definitely gonna get it.
I think the real question, Vlad, is do you have side hustles or do you only have side hustles?
That's a whole discussion of its
own. We're going to let Vlad think about that. We will come back to that question at the theme recap at the end of the month for everyone, and we can go ahead and dig into that. This has been awesome. I will say we've had a number of comments that have come through. We have not had a chance to get out to everyone's comments, which always means that it's been a fantastic show. Courtney and or ourselves will be in the comments going ahead and answering all of these after the show for all the folks currently listening. We've also had some comments that have not come through, which again happens after we get a lot of comments and again directs us to it being a good show. So thank you everyone for that. Courtney, last question for you is who should reach out? How can our listeners help you?
Ooh, so I'm definitely in the market for projects right now. I'm trying to make some hires and I'd love to keep them busy. So anybody that's got questions or interest in automating a process, again, my side of life is kind of the industrial and manufacturing side of life, but anybody that's potentially thinking about putting a robot even in places I'm not good at putting them, I can put you in touch with somebody that understands restaurants or casinos or wherever you're trying to put a robot. So really, if you're trying to put a robot somewhere, reach out to me.
I love
it. Or camera or a PLC.
I think if you're trying to put a robot somewhere, call me. I think that's just your tagline. I think that is very succinct. I think it is awesome. This has been an awesome conversation. Thank you so much, Courtney. It has been so much. I realize now that we didn't even really get into the automation ladies, which I feel like we promised that we would get into. So we will go ahead and make sure to drop automation ladies contact stuff below. Vlad and I have been on the automation ladies earlier this year. We've had now all three of the automation ladies on the show. As I told Courtney, I feel bad it took us this long to complete the trifecta, but we had to wait for the perfect theme of robotics to come back around so we could get all of the robotics goodness and the robotics and business goodness out of this. So thank you very much for that, Courtney. Thank you, everyone, for coming and hanging out with us. If you are already not connected and following Courtney and Vlad and myself, please feel free to go ahead and do so. Please make sure to follow Manufacturing Hub Network on LinkedIn, on YouTube, and all of the places that you can go ahead and do. Thank you to Solus PLC for sponsoring this. And if you guys would like and have made it this far in podcast form, please give us 5 stars. Please go share. Please do all of those things. As I have found, if I ask people to like and share, Courtney, people ask and share in the podcast and the show continues to grow. But until tomorrow, because we've got episode 2 of this week tomorrow, which I almost completely screwed up, we'll see everyone soon. Thank you. Bye-bye.
Thank you, Courtney. Thank you, everyone.